And now we're looking back to see how we solved those last two problems there in number 6 and 7. And it says, compare the strategies you used to find the volume in the two previous problems. How were they the same? How were they the different? In both prisms, I labeled the length, the width, and the height. Now the difference, I actually provided two differences that you could talk about, and there's certainly more differences. The difference was that in number 7, I used the volume as big B times H instead of the length times width times height. But I do understand we could do length times width times height in both. Another difference you could discuss would be the fact that number 7 was much easier to count the lengths of each sides, whereas number 6 was a little bit trickier, and you really have to be much more careful when you're counting that. So either of those answers would work, or I'm sure you may be able to come up with another a couple possibilities. Number 9, we are splitting up a square into fractional side lengths. So if you look in this first one here, we have 1/3 side length. So what I recommend is think of 1, and we are going to split it into thirds. So third, third, third. So we're going to split it up into 3 equal pieces, both for the length and the width. So you can see here it's split into, that 1 is cut into 3 equal pieces. When we split it into 4s, now this 1-inch side is split into 1, 2, 3, 4 by 1, 2, 3, 4 boxes. So you can see that the pattern here is that the denominator actually tells us how many boxes we will have for each side length. So since the denominator was 4, it's going to be 4 by 4. The denominator was 3, it's going to be 3 by 3. So now let's look at the question here that they're asking us to solve. How many squares with side length 1/5 inches will fit in a 1 square inch? You may draw a picture to help. So we look at our denominator as 5. So I need to split this square into 5 equal pieces as best as I can. So 5s are always a little tricky, so I map it out first. Here's 2, 3, 4, 5. Now I'm a little off. So what I'm going to do is, if this happens and your sides aren't quite right, we can always erase and try again. It doesn't need to be perfect, but we want it to be as close as we can. There, that's a little better. I'm going to connect everything. Again, it certainly doesn't need to be perfect. We don't need to measure it out. And now we can see that we have 5 squares going up and 5 squares across. So how many squares total? We could do 5 times 5, and there will be 25 squares for this picture.